Trey said, my name is Sterba. I'm a current senior at East Aurora High School. That was an excerpt from Aggressively by Robert McCormick, played on the snare drum that I constructed last year. I'm going to tell you a little bit about the study. In February of 2021, I received approval to conduct my own independent study in the Department of Technology at East Aurora High School. It studied the audio spectral properties of a stave snare drum, which included tuning range and amplitude. More specifically, it studied how these properties compared to the more commonly used ply construction. To accomplish this, I designed and fabricated a 20-piece stave snare drum, which entailed building my own machinery to make the drum, like the outer diameter lathe, router sled, and inner diameter lathe. Unlike a ply drum, a stave drum has thicker shell walls, denser materials, and far less glue is used, which can be known to deaden the sound of the drum. Anticipated results of the study included wider tuning range and a higher amplitude in the stave snare drum. The drum was designed to have a 12 7/8 inch diameter, 6 inch depth, 3/4 inch shell wall thickness, and a hard maple stave construction. This project posed many challenges to me, but by far the biggest was gluing the drum. Due to the extreme precision that this step required, I thought it would be the best idea to glue the staves into sets of 2, 4, 8, and eventually 16. This eliminated many alignment factors and kept my tolerances as low as possible, which means there are no gaps between the staves. As I said before, machinery designed and fabricated included the outer lathe, router sled, and inner lathe. I'll tell you more about those in the next slide. As you can see from the plans, the drum was not round after glued together. I did not have a commercial lathe big enough to round it, nor did the school. I solved this problem by making my own, using a drill motor, plywood, and a router as a tool. The lathe was so precise that it had a circularity tolerance of a little over 1/1000th of an inch. Here's a video of it. Next was cutting off the lids and making the top of the drum level. Repurposing the materials from the outer lathe, I built a 2-axis router sled that leveled the drum within 1/10 of a degree. Here's the video on that. To round the inside, I repurposed my materials from the router sled to make the inner lathe. I also used rollers taken from an outfeed table so the drum would be stable as it spun while being machined. To measure its audio spectral properties, I designed a tool that would measure head tension. This tool pressed a pin into the drum, so the looser the drum head was, the further it would depress, therefore a smaller value would be displayed on the gauge. The conversion formula I derived converted this displacement value into newtons, a scientifically acceptable unit. Measurements were taken from the lowest tension of each drum to the highest. Their primary frequencies and amplitudes were compared. The results are as follows. Results of the study showed 115% higher tuning range and a 9.4% higher amplitude in the stave drum. I believe this is due to denser materials, thicker shell walls, and less glue. As of Monday, the 15th, the study was submitted for publication in the Journal of Sound and Vibration. I'm awaiting its approval. I would now like to take a moment to recognize those who made the project possible. Mr. Brian Cray, Department of Technology, Mr. Ryan Wall, Department of Technology, Mr. Ethan Hansen, Department of Science, and the East Aurora Board and Administration. Without all of you, this project would not have been possible nor successful. Thank you.